everyone, George here, and we are doing some math. In the last video you just saw, I tried to cut it down because there was a lot of me messing up, but I screwed up all the math and got everything wrong. So I decided to take a little bit of a break, picked up my kids, got home, put them to sleep, or at least they might be asleep, and I sat down and I really quick came up with a way of doing this that's a little bit different. So the door itself is important, and its forward vector is important. What we're going to do is take the position of the door, and we are going to also take the position of the NPC character that has intersected the door, and we're going to get the vector that goes from the origin of the door to the NPC. We are then going to flatten those vectors by, of course, converting them over to vector 2s and only looking at the X and Z components. And we're going to normalize them, something I forgot to do last time, since when taking two of the components out, it's a very good chance that the Y component's gone now, and that's no longer normalized. Then we're going to dot product those two together. And we're going to do a split in our logic. If it's greater than 0, they're going to be on the same side. That is as if this was on this side instead. If it's less than or equal to 0, and I'm just doing the less than or equal to 0 because whatever, it's going to be on the opposite side. And then what that means is if they're on the same side, what I actually want is for the door to open towards negative DF, because that means that this guy's over here and I want him to cross over here. So I need this door to go, well, sort of that way if the pivot was elsewhere. And on the opposite side, if they are on opposite sides, I'm going to want this to actually go towards D positive, to go this way. And hopefully that is going to be really easy to implement. The idea is that when I do the rotations, I'm going to do a start vector and an end vector. The start vector is just going to be the right vector, whatever it happens to be. So that's going to be a vector that's just sort of sticking out of the door like this. And then I'm also going to store the initial forward vector, because when you rotate this thing, the forward vector is going to be all over the place. But I want it to rotate all the way open, so I'm going to store that initial forward vector and use that in my case. All right, so let's jump back over here, and we're going to gut a lot of this code already. I'm going to move, let's see, I have a second monitor. I'm going to move the logic that I just came up with over to that side so I can reference it. Let's see here. So we have rotate door. So we have this is open thing, and really is open isn't what we want. Really what we want to do is check to see whether or not the angle is of a certain size. And if it's big enough to allow the animatronic through, then we do nothing. Otherwise, we need to do something. But for right now, we're going to leave the is open thing because it's just easy to implement. We're going to have to work on this when we start messing with the player, handling the doors and opening them and closing, which is going to be pretty soon. So some of this stuff we can get rid of. I'm going to get rid of minimum angle. I'm going to get rid of, okay, we're going to keep pausing the path direction. We're going to use this animatronic direction and door directions, extracting the vector 2 components. However, we need to do some logic first. We need to come up with that forward vector, which is easy to get. And then of course we need this NPC vector as well. So let's create those. So we're going to do, let's see. So we have path logic.gameObject.forward.trans. Actually, that's this right here. Let's just call this DNPC instead, and then D forward. And actually, like I mentioned before, I'm going to store the forward vector before it gets modified that it's set to when the game begins. That is my neutral position. That's when the door is closed, and that's what I want to get back to if for some reason I do try to close the door. So let's go ahead and do that. Vector 3, initial forward vector is going to be equal to this dot transform dot front forward, excuse me. There we go. Let's declare the variable, and then let's actually put it to some use. Initial forward vector is equal to that. And there we go. Now that we've got that stored, let's come on down to our rotate door. So we have this component, we have this component. We're going to, actually, this is incorrect. DNPC actually needs to be the subtraction of two vectors. So first, let's do this. Let's get the vector that goes from, we need the vector 3 direction to NPC is going to be equal to subtracting the NPC's location, which is path logic.transform.position minus this object's position, so this dot transform dot position. That gives us that vector. Now we're going to actually take this vector and rip it apart instead of the other one. So I'm going to get rid of, actually, all of this nonsense and just keep the X component. And we're going to do that again right here so that we only have the Z. Let's pretty that up a little bit. And then we have this component right here. So we've got the two now, and now we can do the dot product between these two. So at DNPC, or direction NPC and direction forward, that's going to return to us our positive or negative value. Then we're going to do our test to see whether or not the dot product is greater than or let's see, actually this we don't need anymore for right now. Actually, no. Do I want to do this? The only difference between the logic here is that the direction changes. So I can still use the same principle here where I just negate it or, make it positive. So, and whoops, in our case, what we want to do is if the dot product is greater than 0, we want to open the door towards the negative side, which is good. And then if the dot product is less than or equal to 0, we want to open it towards the positive side. However, these aren't what we want. We want going to open it towards initial forward vector. And we want to negate one of them. Let's see. This needs to be a vector 3. Okay. So then that's perfect. So now we either negate the forward direction or we go towards the forward direction. Now we do the actual moving part of this. Let's close this so I get a little bit more room. And make this bigger. So let's see, we do an if is open, if not is open, then what is this crap? So this is never going to happen because if it is not open, then we open it. So let's get rid of the logic of closing this thing. So if it's open, that's this logic. We're going to get rid of that. We're just going to do this. We're not going to have the animatronic capable of closing doors yet. If we want to add that functionality in the future, we certainly can, but we're just going to ignore it for now. So we have while current time is less than duration, increment the time. Now what we want to do here is we're going to use, we need to move towards from the right vector that we start off with. So let's store that. So we want a vector 3 right vector. It's going to be equal to this dot transform dot right. And the reason I'm choosing the right vector is if we look at the world, the right vector is always pointed inwards towards the door. Okay? And we're going to go from this orientation to wherever we want this orientation to be, which is going to be our forward vector. So even if it's rotated, say, this much, well, that is still our orientation going this way, and what it's going to want to do is to return to this orientation here. Okay? Hopefully that makes sense. Hopefully it works. I haven't tested any of this stuff out. So, all right, so we're iterating. We're going to get rid of this angle thing, and instead we're going to do this dot transform dot local rotation. Let's do actually a float angle. Actually, no, we're going to do a quaternion. Quaternion orientation is going to be equal to quaternion dot, and then we want the one that allows us to go from to rotation, I believe is what we want. So from vector and then our to vector. Actually, we want slurp, don't we? Let's do slurp. Can I do slurp? That's quaternion 1, quaternion 2. What I actually want to do here is create a vector 3 lerp. That's going to be the vector that I am moving towards with each time step. And lerp is going to end up being vector 3 dot lerp. And we have vector A, which is going to be our right vector. Actually, we don't need to store this because no, we do need to store this. We're going to store that. Then we're going to have the end vector, which is our initial forward vector. And then what we're going to use now is our current time divided by our duration. So the idea being that this value here, this lerp value, is going to slowly move from our initial position to our final position based on this right here. So then we'll do quaternion.orientation.quaternion. From to rotation, and we're going to, our from rotation in this case is going to be our current right angle. So let's do this dot transform dot right, and then our next one, which is the lerp angle. And now we're going to use that quaternion here. Excuse me, that orientation. So instead of doing this stuff, we're going to just set it equal to that. So orientation. Then we stop and we keep doing this over again. What we're going to want to do though is that when we hit the end, this current time could be greater than duration, in which case our door is going to move beyond its area. So we're going to hard set this rotation here. So let's grab, let's see, this line right here. And we are going to just do whatever our current rotation is and set it. So let's see, I know you're there. We'll do final orientation. And this is going to be this.transform.right. Instead of lerp, this is going to end up being our initial forward vector. And that should end, that'll make a rotation from wherever we currently are to that, and it ends the whole thing. Okay, so I think with that, we're ready to go. So jumping over to Unity now, I'm going to clear this out. Okay, and I'm going to go ahead and turn on, just for the first part, the nav mesh agent. And let's hit run, see what happens. Interested in seeing what happens. Okay, it opened the wrong direction. All right, because it did the wrong thing, we're just going to stop it, turn off that nav mesh agent, hit run, and give this another go. Now that this is orientation independent, I should be able to just move. Wow, look at that. That was not good. None of that's good. It's saved. So what's going on? Okay, well, one thing I did forget to do is normalize. So let's do that. npc dot normalize and the forward dot normalize. Okay, so those vectors have been normalized now. Now the dot product is going to return a proper value. Although technically I don't think this matters because I'm really only caring about positive or negative. So I don't really need to normalize it, I think. Okay, one thing I think that is wrong is I think I need to actually do this on world rotation now and not local anymore. So we're going to change that up. You know what? I think there's an easier way of doing this. Now that I think about it, couldn't I create a quaternion to the right location right at the beginning and then use slurp to do the rest? So do quaternion.slurp. Instead of the lerp here, I'm going to do a quaternion, I'm just going to call it temp for a second here, and then quaternion and dot from to rotation. And I need to pass into that the starting vector, which is going to be our current orientation. So this dot transform dot right, this dot transform dot rotation, and our final rotation, which we want to be the forward vector, right? So this dot initial forward vector. I think I know why I screwed this up. I was mixing the right vectors and the forward vectors and all kinds of crazy stuff. So this is a quaternion. How about what we want is, we want this to open up to where? To where we want our forward vector to be our final resting place. And our current orientation is, what do we actually want? We want, in a perfect world, we actually want this, which is to have our inverted right vector. So let's try that. So we want this dot transform dot right and negate that. And then we're going to do a slurp from our current orientation to the final orientation. And we want to store the current orientation. So quaternion initial orientation. It's going to be this dot transform dot rotation. So we're going to go from there to temp, or final orientation. It's probably better. And we're going to do it based upon not lerp, but current time divided by duration. And what's going on? Final orientation. What are you yelling at me for? Local parameter, final orientation. Oh, it shouldn't be final. It should be updated. How about that? And then our final orientation is going to be from wherever we currently are, which should be our front vector, this dot transform dot forward to our initial forward vector. Yeah, I have no idea if this is going to work. I think I got to think this math over a little bit more. Quaternions are messing with me. They always mess with me. Boink. That was funny. So obviously it's not working. So let's get rid of the last bit of code, because that's messing things up. This little bit here, I gotta figure that one out. But I want to rotate from whatever my current orientation is. So I want to go from this dot transform dot, or actually, final, what do we want to call this? Final vector. That's what I want to go to. And I'm starting from whatever my current vector happens to be. So if this is forward, I actually want my right vector to go to there. Let's look up from to rotation really quick, because I think I'm misunderstanding how to use it. Okay, so it is in world space, so let's make sure that's correct. So let's do rotation, this dot transform dot forward, and then let's just do this dot transform dot right vector. All right, I think I finally figured it out. A couple changes were necessary, but apparently I forgot how quaternions work. But I figured it out. I remembered. So what have I done? The first thing I did was I made a change to the direction parameter. Instead of returning the vector's direction that I want it to be, I just stated whether or not it's going to be a negative or a positive value. That is, this is going to end up being multiplied by my forward vector to determine if I'm going into or away from the actual forward component. The next part is I define my initial orientation and my final orientation outside of my loop structure. I want to know where I'm beginning and where I end, and then I'm going to just iterate slowly over that by lerping, or actually I could slurp it if I want to, over that range. So first, the initial orientation is just whatever our orientation happens to be. The final orientation, though, is whatever our current orientation is, and this is where I screwed up. I was not taking into consideration our initial orientation. And I multiply that, which is basically adding these two quaternions, by a quaternion.from_rotation, and the from beginning is going to be the this.transform.forward times direction, because what I want is this angle here, this blue, the z-axis here, but I want that angle right there to look like this, where I have it now pointing off to the side, the right side, which is the negated red vector, which is the x-axis. So I instead take my right axis here and put a negative sign in front of it so I get that flipped on the other side. So this gives me that angle, but it doesn't give it from the beginning. By multiplying it by this.transform.rotation, I get a full from here to the end area that I can work with. Then, of course, everything I've done so far, then we go into quaternion.slurp. We have our initial orientation, our final orientation. We don't have to do any more calculations. We're done, basically. And then I just take current time divided by duration. This is going to be a value between 0 and 1, all the way up to that. And then we're done. And the last thing we really need to do is put this thing in its final orientation. And all I need to do for that is, instead of doing any calculations, all I need to do is this.transform.rotation is going to be equal to final orientation right there. And we're finished. So let's go ahead and test this out really quick. Hit run. I think it works. At least when I tried it just a few minutes ago, it worked. And let's grab Foxy. And there we go. And let us see. Now, we're not going to rotate him because it should be orientation independent. So if we click on this one, you'll notice it opens up in the proper direction. Let's come from the other side. Now we come from the other side there. We'll come down from the downside on that one. Then we'll come from the top side on that one. Then we'll just keep doing this, bam, bam, bam. And it's looking like our doors are opening up properly, regardless of what side Foxy happens to be on. So anyway, yeah, that ended up being more difficult than I expected. I think I'm just out of practice, and that's probably why it sucked. Hopefully, maybe you learned something, and I know I remembered something, and I'll see you next time. So long, everyone, and goodbye.